Choose one.
We didn't answer this question, which would have been kind of beneficial. Um, as you can see, Michael Jordan scored more points. We didn't answer that question, but that's not the question I was even after. The question I was after is, what does a box plot show that a bar chart of averages would hide? The variability. We can see variability in these plots, right? There's more variability in terms of Kobe Bryant, right? Oh yeah, that game he scored 80 points. Those in LA, right? Which is fine. And then little LeBron James a little bit more consistent. All right. With that being said, it says all the scoring and assists related across divisions. And low key, they're not, but we're gonna still try to answer the question as best as possible. This one has is interesting. Okay, this one's a little bit interesting. So what I'm gonna do is I'm just gonna do a little bit of a copy and paste because we're gonna need this line, this type of this piece, NBA analysis data frame. We're gonna filter on points as well as conference, but this time not to the conference. We're gonna say divisions because we're looking at across divisions, making sure that every single game has data. And then we're gonna do one more. It's gonna be assist. Okay. So is NA, we want to make sure that those rows are not included in our analysis. So AST, okay, boom. And so how we're going to do this is by way of a scatter plot. So PT versus assist, or assist versus PT. So let's go ahead and do that. So we're going to do geom, or sorry, GG plot, okay, GG plot. And then we're going to do AES, okay, where our x is going to be AST, that's a quantitative variable, and then y is going to be PTS, that's another quantitative variable. So therefore, we should use geom point, and that's going to give us x and y. Okay, so that's across all three players. Okay, so therefore, we would want to do some faceting on that element, right? We can do a like we did earlier, a facet wrap. Nothing wrong with that. I'm gonna embarrass myself. Let's do facet grid, just so you can see how. And if it doesn't work, I'm gonna make it work. Okay, facet player, Kobe Bryant, LeBron James. I think you can add an additional argument to it to be able to specify. There we go. Specify the number of rows and columns. Okay. I think this one is the one. If I were to do this to it would then change you. Still no. Jeez. Notoriously embarrassing myself. That's fine. And so what we can then do is to, let's say, make the points a little bit more transparent so that you can see if there's cluttering or a cluster of points laying on top of each other. So you can do 0.35 as a level. So you can see most of the data points here for Kobe Bryant. They're overlaying on one another, whereas this point you see they're a little bit more translucent, right? Let's say maybe increase the size of these points. So size is equal to 1.5. I think default it is 1. Let's make it 3 for fun. A little dramatic. All right. And so what we can now then do, before I go into this next element, what I can now do is add a regression line within this. So the function for that is called geom smooth, and we're going to say method is equal to lm, and that's going to create a linear line. However, it's going to create error bars. Okay, those little gray regions are error bars. What we can do is to get rid of those error bars is to say SE standard error is equal to false, and then they go away. All right, cool beans. Um, And then last but not least, what we can then do is to specify the width of the actual line. Line width is equal to 0.7 to make it smaller. That's cool. And we haven't added the division variable. I'm out of myself. So what I can now do is add within AES, okay, you can say color is equal to divisions. Is the division. Okay. So you can see green is Pacific, Central is blue, but you know that LeBron James plays for both the Cavs and Miami. So this is why it's Southeast as well as Central. Okay. Um, let's add two things. I'm gonna press pause. I'm gonna add two things to this. I'm gonna annotate on the graph on a particular point for each player regarding the highest assist game can still include elite scoring. Okay, just some text on each graph, just so that you all can see how to do it. And the function behind that it's called annotate. And then I'm gonna put it down here. And then I'm also gonna provide the labels as well as more bricks. So you'll see this in one moment. Actually. So annotating, we're able to then specify location 1415 1455. So around here, some text that says high assist games can still include elite scoring. Okay, like a threshold type situation. But it could be across player based on the player's statistics rather than 14 to 15, excuse me. So I'm just doing this just so you can see that it can be done. Okay, so it should occur at the same spot. Okay, right here. Should comment this out. There we go. Same spot. Okay, if we have 14, 55, that's neither here nor there. We can do that. And then these next two lines continuous to these breaks. We're going to say about every 4 on the x-axis, and then on the y-axis every 10, like we saw earlier. Okay, that we can do that. Every 4, every 10. We're going to add these labels according to the x and the y axes. Okay. And then we're going to make the theme minimal, and then as well provide some more legend and panel grid modifications. Okay. So then once we do this, it looks a little bit cleaner. Okay. As you can really see, it's really a potential association between with Kobe, not so much with LeBron. Yeah, and not at all with regards to Michael Jordan. Okay, so that's something to note. We already mentioned about alpha, so that we can see the clustered points a little bit better. And then let's go ahead and jump right into our home game win rates different from away game win rates. So this one's actually quite long. So let's go ahead and I'm gonna do some manipulation. I'm going to focus on data that we actually have, home and away games, and I'm gonna count the frequencies for the home and away games in terms of the outcome, whether they won or lost. And then I'm going to find the proportion for all those games. So let me go ahead and do that. I'm just going to put it above here. And if you want to do it, you can do it too. Without me showing you first. I'm going to call it outcome location DF. And I'm going to assign it to, or assign that information here. So let me go ahead and get that computer malfunction during the video. That was fun. But I'm back. And so little things. So like I'm gonna get rid of the NAs in terms of home and away outcome and the outcome variable. I'm gonna count by the frequency so I can figure out the frequency of home and away, losses and wins. And then I'm going to group by player home and away to find the frequency, or sorry, the proportion for each. and then ungroup, and then create a new variable called fill key to specify Kobe wins and Kobe losses and so on and so forth. So in terms of the other players. So this is the outcome data frame. Okay, so this is the data frame here. It makes sense that it's 12 because each player has two, home and away, and then they have wins and losses. Okay, so that's that. So 3 times 2 times 2. Um, so then from there we can start creating some, a visualization. So this little piece here is going to look so confusing, but don't worry, we're going to parse it out in a moment. We're going to parse it out in a moment. So we're going to do geom. No, I did it again. ggplot of outcome location df, and then I'm doing it the old way. AES x is going to be equal to home away, home away. Oh no, away, and then y is going to be equal to the proportion. Y will equal to the proportion. Or I think we just call it prop up here, right? Call it prop, the proportion. So you can see the player home and away by proportion wins and losses, right? And let's say we're going to use geom call for the column. And we're going to do some more modifications, but I just want to see what this looks like. So just run this. That makes sense. Just 2 blocks, okay? I'm going to now specify that the fill, right, the color is going to be based off of the fill key, which is the player's game location and whether they win or lost, which is right here. So just run this. Okay, so that's what we see here. I'm gonna add some more specifications. I know it does look stacked, but I'm gonna still tell it that it's stacked. And then the color is white, so we can create there's some little dividers in our colors, as well as specify the new width. So we're gonna say position is equal to stack. Oh, I spoke too soon. I said no mistakes. Color is equal to white. So it's separated by what? The fact that it's white. Right, so you can see that I'm referring to. And then finally, we're going to say that the width, let's make it smaller, is equal to 0.7. Okay, so that's cool. So as you can see, we don't want this really, because it's hard to actually, we don't know what each player is. I mean, technically you kind of see that, but that's really hard to move. This particular graph I did run through AI just so I can figure out the colors of each player, as well as make the colors based off of I'm gonna add percent. I'm actually add text to this as well, and then have the text be a particular color based off of home or away. So let me just do one thing at a time. So I'm going to copy and paste a bunch of code, paste it, and I'm explaining things one by one. So let's go ahead and pause. All right. So the very first thing I'm going to do is add text to each of these proportions based on the player. That's going to be that. So let's do that. See what it looks like. So you see the percentages based on color, which is not the greatest. I'm gonna fast it on player here. I forgot to add this code. I'm gonna fast it on player so we can actually see the difference. And I think I'm doing a facet wrap. I'm gonna do tilde player. Let's see what this looks like. Okay, so then now it's gonna be by player. It's broken up. A little bit better, but it's fine. As you can see, we're going to now make a lot of modifications in terms of the colors. So I would want this to be Kobe Bryant's colors from when he played for the Lakers, LeBron James when he played for the Cavs, and then Michael Jordan when he played for the Bulls. So that's what this line of code where it says scale fill manual. Okay, so add that here. As you can see, the hexadecimal colors right here to our right is specified here. And then we provide the fill, what's it called? Fill key here to specify each player. Okay. I'm gonna uncomment this as well. And then we put a hashtag here and then run. So now it looks a little bit cooler, right? It looks a little, we have some little razzle dazzle in our plot. But something that's automatically apparent is that these pinks are nice, whatever, and these blues are nice, but at the same time, it would be better if these were all white and these colors up here would be black. So what we can do is scale color manual. When it's a win, here it'll make it a white, and when it's a loss, it's a black. We just run this. I forgot to do this. Sorry. Now we have the white for the wins, okay, and the black for the losses. Look at Michael Jordan. Look at Michael Jordan when he's at home. Look at Michael Jordan when he's away. Oh, to tie. Oh, when Kobe Bryant. Oh, let me see. Make sure I'm reading this right. Wins 81, 77, 76. Wins when he's away 53, 53, 50. Oh yeah, Kobe Bryant did better there when he's away. Let's add some labels, make it look nice. Okay. And let's add minimal coloring as a minimal background. And then we can do some things to the actual theme. And let's run this all together. What did there's a plus, I forgot exactly. Okay, boom. There we go. Okay, there we go. Looks a little cleaner. I can make this next line. So do \n, so it doesn't look too clunky, right? And so that's that. And so that's our plot. Okay. Thank you for watching. There is a shiny that I could post so that you all can practice on. I think I'm gonna do it. I didn't mention it I did in my other version, but there's a shiny that you can do some more, manipulation on and go from there. Thank you all for the series. Thank you for watching all these videos, and you're greatly appreciated. And have a great rest of your day.